Hello, my name is Jill Zhang from Lawrence Livermore National Lab. In this presentation, I will introduce to you one of the diagnostics packages developed within E3SM project. We call this package E3SM Diagnostics. E3SM Diagnostics is a modernly designed Python-based diagnostics package for evaluating Earth system models. It is originally modeled after NCAR's Atmosphere Diagnostics Package, but it offers a lot of new features. The program is highly customizable. It is flexible for the users to add new observational datasets, to modify the figures. The package is easy to install, configure, and execute. It runs fast using multi-processing techniques. At the same time, we maintain an updated analysis data repository, which includes most up-to-date observational and reanalysis datasets. The package is developed for E3SM model output, with the consideration of accommodating standard CMIP data convention. Therefore, we anticipate it to be a useful tool for the climate research community. Here shows the example results from current available diagnostics sets. Each three-panel plot shown here consists of test data, reference data, and difference data. We currently have latitude-longitude maps, zonal mean 2D plots, polar plots, CUSP simulator plots for diagnosing cloud fraction, zonal mean plots, tables to summarize metrics, and the Taylor diagrams are also provided. Next, I will briefly introduce how to use the package. We have recently released a version of E3SM Diagnostics, version 1.5.0, with which E3SM Diagnostics can now be ran as a container. The users don't need to create a new environment. Just download the latest image, which is about 3 GB. Containerization is a technology allowing a process and its dependencies to run in isolation. New update further simplifies the installation process for users. This can avoid unexpected installation failure and help us to distribute the software across various machines. The installation is now much easier. For instance, to run with a container on NERSC, Edison, or Cori, the user just needs to download the container and an auxiliary script and run it using E3SM Diagnostics container, the Python file, shifter-p, and the configuration Python file. Here, Shifter is a container runtime available on NERSC. We have the end-to-end quick start guide on our documentation website, which I will show later. At the meantime, we support alternative installation, including install via Conda environment, or you can install the E3SM Unified. The E3SM Diagnostics is available through the unified environment. Running the package is straightforward. For a default run, not using container, after installation, you just need to type in the command line E3SM Diagnostics-p and followed by a Python script. It runs through all the variables through a built-in configuration file. In the Python script, some basic parameters need to be defined, which include reference data path, test data path, and test name to search for data. In this script, you can also set some optional parameters, such as diagnostic sets and seasons. To allow multiprocessing, you should set multiprocessing to true and set the number of workers for processing. If you want to do a short run, for instance, you only want to look at the precipitation, you need to add a configuration file to detail the run. You can copy and paste from the built-in configuration file and modify accordingly. In this configuration file, you can set many more options to customize the run. For instance, the regions to be looked at, the color maps, the contour levels of the contour plots. This slide highlights some parameters might be useful. Options in bold are default ones. We have options to select the diagnostic sets, seasons, and the regions. You can define the pressure levels for diagnosing 3D variables. Save netcdf is a parameter to save the data being plotted, in case there are needs to reproduce the figures. And the multiprocessing options are also available, as I described earlier. For plotting, users can pick the graphical backends between VCS and Matplotlib. The output format can be PNG, PDF, or SVG. Again, color maps and contour levels can be specified. We have all the available parameters documented. Please look at the linked page. Let us know if these are useful and new parameters that are good to add. Now I'm going to present some highlights of the package. One is the provenance capture feature. We try to save as much as provenance to assure reproducibility. First, we save the exact command line during the run for reproducing the figures. For instance, if you want to make changes to the final results and publicate these in a later time, you can just modify the parameters in this command line shown in the viewer and generate new figures. Other than the command line, we also provide the options to save the netcdf files and metrics for resulting diagnostics. The environment files and the configuration scripts are saved as well. We also keep track the original data and the processing script for the analysis datasets we provided. For analysis data development, starting version 1.6.0, we will include newly produced time series data in addition to the CLIMO files, and support the diagnostics using the files with multiple years. In the figure, lists the data sets and years available for each data. We include GPCP version 2.3 for precipitation, Hui OA flux for surface heat fluxes, and Hadley Center's SST data, the series EBAF edition 2.8 and 4.0 for TOA and surface radiation fluxes, MIRA2 and ERA interim for reanalysis data, and AOD at 550 nanometer from Aeronet. If you can look at the years available, we push the years to very recent. At the end, I want to draw your attention to our documentation webpage. We have this page to document all the instructions for using the diagnostics package. Here you can find guides to run the package in different analysis machines. Following these guides, you can easily install it on your home institute machines if you wish. Also provide several examples in Jupyter Notebooks format, including model versus model and model versus ops with respect to support CLIMO files or time series files. I will leave it here. Hopefully at this point I have convinced you to give the package a try. Please drop a line at our Git repo if you have any suggestions. Thank you for your attention.